Hello, hello. I'm going to be talking today about using APIs and sort of a workflow for using APIs using an example from Reddit. So hopefully the example is useful, but even more importantly, the principles are useful. So let me share my screen. Okay, hopefully that's working. Okay, I think I want to move it around just a little bit. Okay, that's maybe a little bit better. Okay, so the kind of principle, the big principle, is that you want to save intermediate steps. So that's one aspect. Another big principle is that you want to save as much of the raw data as you can. So I have, in order to kind of have those two goals, I have a three-step workflow. One is code that gets data from an API and saves as much as possible of that data to a file. A second program, which is usually, I'm putting all these programs in one file, but usually I would keep them in three separate files. The second file loads data from the API, loads the data that we've already saved, from the API, extracts what we want, creates measures from it, saves it in a flat file like a CSV file, and then the final program loads the CSV and does the analysis that we want. And so this has lots of benefits, which we can talk about, but one is that sometimes it's tough to get the raw data again. If all of your pipeline is all combined, and so you decide you want to change, worst case scenario, you decide you want to change the color of this histogram, then it goes in, because of the way you've written your code, it goes and gets the data again from the internet, does all the cleaning steps, and then creates this histogram. Sometimes you're going to be in trouble because maybe the raw data isn't available anymore. Maybe you are looking, so Twitter used to let you only look at the last week. Reddit has a bunch of APIs that only get the last 1,000 posts or something like that. And so if you run it again, you'll get another set of 1,000 posts. And so obviously this can cause trouble. If you're doing analysis later on, you just would be out of luck. So we save as much as we can. This also gives us a nice pipeline that there are lots of this process. As you'll see right now, the data retrieval steps can be really slow. Sometimes can take months, in the worst case. And so we then, some of the other steps, like the cleaning steps, can also be really intensive. And so we don't want to do those over and over again. We want to do as little as possible. So wherever we make changes or decide about different direction to go, we go as far upstream as we need to, but we have intermediate files that help us. So we don't have to go all the way back to the beginning. We just go as far as we need to and then change everything that's after that. So we're going to use PRA for this. So that stands for the, right now I've forgotten, Python Reddit API wrapper. And so again, I would usually put these in different files, but this is just an example, and I want to keep it all together. So our first program, if our goal, let's think about what we want to get in the end. We want to characterize how people participate in the Produce subreddit. So we want to create a histogram of the number of posts per person, number of comments per person, median comment length per person, and a scatter plot between the relationship between the number of comments and the median comment length. So to do that, we want to get as many comments as we can from the Produce subreddit. So that's what we're going to do. So we're going to start by doing this authentication piece. Check my last video to learn more about this. You will have to have an account on Reddit. You'll have to have created an app on Reddit. Then you get and you'll have to, in the same folder as this file, get the Reddit authentication, have a Reddit authentication.py file that has your secret info. So I'm not positive, and this is typical when doing work with APIs. It's not always obvious what the best way to do something is. And so I'm not positive that the way that I've chosen is the best way to do this. There used to be a great way of getting historical Reddit data that is called, PushShift. Unfortunately, Reddit made some changes to their API to make it more restricted, and also negotiated a takedown some of these historical options like PushShift, which is it's a real bummer. In general, web data is more difficult to get now than it used to be, more difficult than it should, and it's slowing down social science. But with that aside, to the side, it's still possible to get really reasonable amounts of data from Reddit, even if it's not as vast as I would like, and as I think would be good for science. Okay, so what we're going to do, we can get 1,000 submissions at a time from Reddit. So it's a little bit complicated. I'm going to show sort of a complicated version of how to do this. In the case of, because you may have a situation which is more data than this and that you'll want to run in the way that I'm showing you. So we're going to do two things. So we're going to have a submissions CSV file which keeps the status of the submissions that we've retrieved. And so you can see what this is doing. We create a CSV writer, we give it a header, that's what this is doing, and then this says for each submission in the Purdue subreddit that are the top submissions. So because we want to get as many comments as possible, I decided to get the top submissions, which are the ones that received the most upvotes, I think is how it's calculated. So ones that have received a lot of attention, and therefore I would think a lot of comments. And so limit equals none, and then I'm doing time filter is a year, so the past year. You can do all time, I think, so that would give us the most overall time. But if we want to know something about recent, I mean, you could do whichever. That's what I chose to do. I realized when running this that sometimes if someone has removed their account from Reddit, then the author name is no longer available, but the submission still is. And so we had to include a try and accept. We put the name here, set it to none if they don't exist. Otherwise, we set it to the name here, and then we write out the response. And I should have started this already. It's actually fairly quick. I didn't know how long it would take. So this is just, part of this was actually error handling, just making sure that this was reasonable. I went and checked on a few of these just to make sure that what was going on. And it looks like it's someone who removed themselves from Reddit. Pretty sure that's what's going on. Okay, so now it's done. That was actually pretty quick. As you can see, 15 seconds. If I want, I can look at it over here. Let's look at the submissions. So we have submission ID, the title of the submission, the person who submitted it, the time it was created, the timestamp, and then whether I have comments retrieved, which I just set to false for all of them. So that's whether or not I've retrieved the comments for that submission. Next step is this is the part that takes a while, and this is the part that's a little bit more complicated. So we load that submissions file as DF. I could have called it something else. But the cool part is this is written so that you can pick up where you left off. It'll kind of keep track of what it's done already, and then it'll start at that point. So let's look at what it does, look at the code a little more closely. So first we write a header, and in this case, I mean, there's actually lots of data that's part of this. For some APIs, they will give you directly JSON, and then you can save that JSON to a file. And that's usually a reasonable and a good way to do it, because then you can just sort of save everything that they give you when you make a request. For better and for worse, the Reddit API is pretty tough to navigate, and so they try and make it more accessible, and so they're sort of doing a lot of stuff behind the scenes and giving you objects instead. Maybe there's a way to get the raw JSON. I don't know the Pra API well enough to be confident in saying this, but I didn't see an easy way to do it. And so what you have to do in that case is you then have to kind of select the information that you want to keep. And I was like medium liberal in the way I did this. If this was for a real project, I would actually keep more than this. I would sort of try and figure out what I had available to me and really try and keep just about as much as possible. Anything I think there's any chance that I could want later on down the line, because it could be really tough to get it again. So in this case, I have the ID of the post, the body, the author, the created time, the parent ID. In other words, if it's a reply, who is it replying to? So this could let us do, build networks, for example. The submission ID, so that's what was the post it was written on, awards received, upvotes, downvotes, and the total score. So that's what I've kept. But again, if I was doing this for a real project, I'd think very carefully about whether there's any chance I might possibly want anything else and then just grab it all. Grab as much as you can. You know, the saying is disk is cheap, which in other words means like you can store lots and lots of data, especially this sort of text data. I mean, it just does not take up much room at all. And so you should just grab as much as you can because you may want it. Okay, so then what is this part doing? This is the complicated bit. So for submission in our data frame, our submissions data frame, and then we're filtering to only where comments retrieved is false. And we're going to get the ID. So in other words, we're going to take this data frame, we're going to look at the IDs, we're going to get a list of IDs, but only where the comments retrieved is false. Right now it's all of them, but the key idea is that as time goes on, they will switch to true when we retrieve it. So how does that work? So we set the submission equal to the Reddit submission with that ID. I probably should have called this submission ID. In fact, let's do it. For submission ID, so ID equals submission ID. Okay, and we also are going to need to call this submission ID. Okay, so it's retrieving comments. It tells us it's retrieving it. We set the submission equal to the submission with that ID. We have to set a, again, this is just part of how PRA works and how the Reddit API works, some of the complications here. This is a setting that says how deep should I go? Do I just want all of the first level comments or the replies to the comments or the replies to the replies or replies to replies, etc. So this says we want all of them. If we set this limit equal to none, we want everything. Okay, so we're gonna then make a list of all the comments for each submission. Because we're gonna then once we're done, we've written that out to a file, then we'll mark that submission as done in our file, so that way we won't come back to it. So we keep a list of the current comments. So for each comment in the comments for that submission.comments.list. Again, this all just comes from the PRA API. We're gonna again do the same thing we did before. If people may have removed themselves, so we have to set the name equal to the author name, or if that doesn't exist, we'll set it to none, and then we add it to our comments list, and we just get comment.id, .body, the name that we created, etc. So these are all attributes of the comment, and again, the PRA API documentation is where you can find this, or if you grab one comment, VS Code will let you autocomplete. In fact, I can show how to do that really quick. I'll show how to do, let me show how to do that. So if we had, let's just show how one would work. Reddit.submission, and then let's just grab one of these. Oh, thanks. Here, I'll turn off Copilot really quick, because it is just getting in the way. Let's grab one of these. I don't know if they will have comments on them, but let's check. Hopefully it'll have at least one comment. Reddit.submission. What do we need next? .comments.list. Okay, let's see if that has any. Okay, it does have one. Great. So then if I've got this, and because I looped through it, the variable comment is going to be the last comment in that list. And so we'll just get rid of all of that. And because comment is still in our, there we go. So we have a comment here in VS Code. What I want to show you can just put dot, and then it will show you all of the info that you can get, all the attributes of that comment. So you can get some of these are doing things, right? So block is actually a method that you can block. I think it lets you block. I don't know. Most of them, I have no idea what it means. But you could do, awarders, I think, is who gave it an award. So there's a bunch of this data that you can get, and you can just hit dot and then look through these. Some of them, it'll say nothing. Some of them are useful. To be honest, I don't know what a lot of them mean, but it's worth looking. So for example, you might want to look at the depth of the comment, right? This is the fourth comment down, so it's a reply to reply to reply, etc. So maybe something like that could be useful. Anyway, that's one way to look through it and figure out what you might need with PRA. Kind of an aside there, apologies. Okay, so back to our program. We're going to go through all of this. We're getting all these attributes. We're putting them into this list up here. And then once we've got all of them for one submission, we open up our comments.csv file. A means for appending. Oh yeah, there we go. So up here we checked if it existed. If it doesn't, we gave it a header. So then we can open to append it. So this means we don't override it. We just add stuff to the end. We create a CSV writer object, and then we do write rows. So this takes in a list of lists and writes each of those to a row. So that's what's going on. We'll write all the comments to the CSV file. Then the key thing is we go back in to find where the df.id of the submission equals the submission ID. Submission. Oh yeah, I guess we can get the submission ID either way. We could just keep it here. In fact, that's why not submission ID. So where that where the ID in our original data frame is equal to the submission ID that we're looking for, that we're looping through, we set comments retrieved equal to true. So we change it from false to true. That way, if we stop and we restart this loop, it will not appear here. It'll get filtered out. And so we'll just have the ones that are true. I should have started this right away because it actually takes a long time. But I want to show you. So I think it's nice. So you want to kind of make sure, like, get a sense of how long things are taking. If you're going to be taking your whole life, then sometimes you're going to want to change things. Sometimes there will be like you accidentally included like an infinite loop. And it's not working, and you think it is. So I think it's nice to print something while this is going on. You can kind of get a sense of, is this taking a little bit of time or a long time? It looks like it's really only taking, maybe a second per submission in general. And we can look. It's actually pretty cool. VS Code does this. We can actually scroll down. Here, let's zoom in a little bit more. Let's see. Oh, there we go. And we can just watch it change from false to true as you go along. So we're about 100 in. I think that's kind of fun. So that'll be going for a little bit. I do want to show, though, that we can also, let's stop it. Let's see how far we got down to, there we go. So we got to about 143. When I start it again, if I push start, then it will automatically start back at that same spot, right? See, so it's already all the way through to 156. So that's kind of the key idea, is you want to think of ways that you can save your state, save your where you are, and then start over again. And the reason I could feel pretty confident about stopping it is because ideally I stopped it after it wrote this, and it writes the old comments to the comments file right around the same time that it writes to the CSV file that it's done. So there's a tiny chance that we'll actually end up getting stuff multiple times. Like it'll have written it to the comments file before it writes to the CSV file, but it's a pretty vanishingly small time when that could happen, and it's not. Like more often where things are going to go wrong is up in here where we are retrieving the comments. The writing part is actually very fast. Okay, so that's what's going on. That's going to run for a while. I don't remember how long it took, but I mean, I guess, we're probably in 300s or something. So while it's doing that, I'm going to talk about the next thing, which is data cleaning. So this program loads the saved raw data. So we get the things we want from the saved raw data, we create new measures, and we save it to a new CSV, like a cleaned CSV. So this way, if we want to, for example, change the measures we're using, we just change this file, and then we reread the raw data file and get stuff, and we get it for this file, if that makes sense. We alter how this file reads it instead of having to get the data again. It's great. So what are we going to do here? We are going to read the comments, all of them. We are going to create a new measure called comment length, because that's not something that we got, right? The comments did not say the length, we just have the body. So we're going to get that using Pandas. Has this nice string.length function. So it's how long, how many characters is each comment. And then we are going to, because we want this by person, right now it's by comment, we have information by comment, we want it by person. So we're going to group by author and then use this aggregation function in Python. We are, the way that the syntax works or can work, it's actually kind of a confusing function, but we're going to create a new column called num comments. And the way that is created is it takes the column ID and applies the function count to it. So it didn't really matter which column I chose. This is just counting how many comments there are by each author. And then for the median comment length, we're going to take the column comment length and apply the function median. For median score, take score and apply median. And then we reset the index. So the next thing we do, this does not have the number of posts, you'll note. So we'll have number of comments, median comment length, and median score. So we have to get that from the submissions file. So we get that, we do the same exact thing, load that, and aggregate. We group by the author and aggregate. We just count how many. There's actually an easier way to do this, but this is fine. So we are going to call it the number of posts, num posts, and again, we count the IDs for each author. And then we merge them together. So this says that we want to pandas merge these two data frames, commenter stats and submitter stats. How do we merge them? By author. So they each have an author column, and it matches. So we want, whenever those two match, we are going to merge them together. And then how just means that in this case it shouldn't matter because I think they all have just one author column. It should appear both, but it means that we'll keep everyone in here in the commenter stats, even if they don't appear in the submitter stats. Actually, that is good. We do need that because some people won't appear in submitter stats because they won't have submitted anything, but they will have commented. I guess it could be the other way as well. I should probably do an outer join, but let's assume, just to make my life easier, that we only want people who have commented at least once. You know, maybe we have reasonably the people who have posted but not commented aren't really community members. It's people trying to spam or something like that. So that's my justification to save myself a little bit of work and thought about this. Okay, so it's going to take, we have to wait until we get this comments.csv file. So let's see how close we are up here. It's been 4 minutes plus however long it was the first time I ran it, which wasn't too long. And we have, let's look at our submission. Let's see how close we are. Oh, we're getting close-ish. Close-ish. Where are we? Sometimes it slows down a bit because PRA handles, if Reddit tells us, oh, sorry, you are making too many requests, then PRA will slow us down until it's done. So we're about 800 through. That's kind of slowing it. Well, let me see if this will read. This is risky business, but let me see if this will read the comments while it's writing to it. We might cause ourselves trouble. Oh, it won't because it needs to be sequential. Okay, because the kernel is still running the last request. So it's not going to do that until it's done. I may just have to pause the video so as not to bore you to tears. I will do that when we come back. It's sort of like when you pull the pie out of the oven that's already been baking. That's the experience you're about to have. So let me pause the video. Okay, we're back. We have all the comments. If you want, I should have mentioned, I accidentally stopped it again. I think it took about, 15 minutes. It's not that long, to be honest. Go, start it and then go, make yourself some popcorn. I don't know. If you don't want to wait that long, if you just want to make sure that you can do this, you can. Sorry, I'm trying to figure out where it is. Okay, right here where we are getting the submissions, where it says limit equals none. This means get as many as possible. If you only want to get 100 or 200, you can change that right there, and it will be quicker than what we just experienced. But it's not that bad. It's not that bad. I want to show that, it is, again, a pity that they have cut things down so much. But even now, we have, in fact, let's just take a quick look at, we'll run this. But then I can also, let's make sure that worked. But I want to show just how many comments we got in 15 minutes. So it's 5,000 commenters. And then it is, let's see, what did we call it? Comments DF. No, that's not right. I could have sworn that's how it worked. I'm pretty sure this will show it. So we can just scroll to the bottom. 24,858 comments, right? That's pretty cool. It's pretty cool that you can get that much data that quickly. You can imagine if you had, multiple subreddits that you were doing this in, or across multiple people. You can really get quite a bit of data still. If you have something set up that runs for 24 hours a day, it's really still reasonable. It's just a little bit trickier to get to than it used to be. Okay, so So we've done our thing, right? So we've got our submissions and we've merged them together. So now we have an author, number of comments they've made, median comment length, median score for their comments, and the number of posts that they've made. Yeah, so I've sorted by number of posts, but yeah, that's what we've got. So we've got everything that we wanted. That's great, and then we want to save it. Once we've created it, we save that to cleaned data.csv file, and now we are going to analyze it. So this can obviously include lots of things, but basically we're ready. We could, in fact, this often for me isn't done in Python. I do it in R, but this is where you can send it to Stata or to SPSS or whatever. You've got a CSV file with variables in it, and so you can do lots of things at that point. Typically CSVs work fine. There are maybe some better files that are quicker these days if you have really big data, but I don't want to get into that. We'll leave things simple. So we've got this CSV file. So let's just make sure it loaded okay. Oh, I didn't load it actually. That's our problem. Make sure it loaded okay. That looks great, unsurprisingly. So yeah, that's great. So let's do the analyses we said we wanted to do in the beginning. So let's look at the distribution of posts. So this is using Seaborn. There are a number of packages for visualization in Python. This is one of the more popular ones. So this is the histogram plot, histplot, with the number of posts and the x-axis. Data is our data frame, and this just sets the bin width, so how thick the bins are. I use that especially here for distribution of comments. Both of these are, as you can see, very, very highly skewed, where there are many people who make one post or one comment, and a few people who make many comments or many posts. So this is very typical of online locations and online behavior. If we may be tempted to think that maybe there's something different about like people who only comment once, they're just coming by, they, it doesn't matter, they aren't really part of the community. So if we get rid of them, then we would see like the real community. Turns out if we get rid of them, it looks exactly the same. This is called a scale-free distribution, meaning which comes from the idea that no matter how you zoom in at what scale you're at, it looks about the same. And so if you change this, and you can change it to 4, it looks the same. Change it to 6. Maybe it's people, once you've made 6 comments, it's different. No, it looks the same. It basically always looks the same. So so you can play around with that. It's kind of fun to see. But it's always going to be this highly skewed distribution. Okay, so I'm just going to quickly show you how to do. So this is really just for fun. You'll have to figure out the analysis that you want to do, but just showing kind of how easy it is to do these sorts of analyses, and what this might look like for this sort of data. And again, a key idea is that if you decide you want to do a different analysis, you're only changing the way that this third file works, right? You don't have to change how you create the measures. You don't have to change how you get the data in the beginning. So you just go as far upstream as you need to. Okay, so these are really highly skewed. We're comparing comment length and the number of comments. We don't learn anything from that. So we are going to log both of them. So we get the log of both of them and try again. That one looks much better. Look how nice that comment length is. It really is a log distributed. The number of comments still is super skewed and looks crazy. But maybe if you kind of squint, there's a relationship, there's a correlation here. This is the best fit line. So median comment length and the number of comments made appears like people who comment a lot also write longer comments. Although, yeah, there's quite a bit of the median comment length is pretty close to the same. Okay. So for fun, let's look at the score as well. We kept that around. So median score, here's what it looks like. It is, oh yeah. looked at that with just the people who had at least 5 comments to see if it was any different. Again, I tempted myself to think things would look way different. In this case, it kind of makes sense, right? Because there's like some statistical noise that if you have only commented once, then your median is going to be the same as whatever you commented. But if you commented twice, there's kind of a regression to the mean, and there's, if you just happen to say a really bad comment or really good comment the first time, chances are it will come back towards something more normal. So in this case, there may be some reasonable reasons to exclude people who've only commented once or have commented less than 5 times or less than 10 times, etc. But we'll just leave everyone in there for fun. So this is all of the scores. You can see most of them are quite close to 0, with some skew and some negative. And again, I tried to log both of them. Logging the median score is quite complicated because it can be negative and you can't take the log of a negative. So I added the minimum score, so I made them all positive. In fact, they're all at least 2, but still it's a little bit messy and ugly. It's still a very strange distribution, and so there's some weirdness going on there. There's maybe some evidence that as the score increases, the number of comments, it's negative. The score increases, the number of comments decreases. So I guess really I should have flipped them, because I'm thinking of the score as the outcome variable. So as you have more comments, your score is on average lower. So, which is surprising, kind of the opposite of what I would say. But again, I would take that with lots of grains of salt based on the distributional weirdness that's going on here. Welcome to the world of trying to extract information from online data. It's very messy. There's a lot going on. And so I hope you don't take too much from the analysis. That is certainly not the goal. There's a lot more work that would need to be done in order to create some believable findings or learnings from what we've seen, but just really sort of an introduction or a kind of example of the sorts of things that you could do really pretty quickly with this sort of data where we're going from nothing to having 30,000 observations and plotting it really in a few minutes, and that is sort of the wonder of online data. So thanks.